This video is for someone that might have bought a Collins 51J-4-3-2-1, whatever model. I'm going to go over the two different tuning knobs. Now, I showed you in one of the videos me turning the tuning knob, which is up here. You can't see it's out of the front. Oh, it's up in here. When you turn this knob up here, it turns gears. It turns a cam, which moves pistons up and down inside the coils that are on the front end RF amp, and then after the mixer. Now, this knob down here goes in through here. Here's your gears. Here's your crystals, and here's the would be the main wafer switch for changing coils. Now, when you turn, I'm going to go from D10 to D10. Normally, when you turn a band switch on a radio, it'll move maybe a ½ inch. Watch how this one works. Let's hopefully the camera. I'm going to go up in frequency. Okay, I've already started turning the knob. You can see the gear. Hopefully we can see the gear on the bottom moving. And we're still not, now we're in the next D10. And you're going to say, why? All right, here's what happens. When you turn this knob, it turns the wafer switch for one of the crystals that's used in one of the mixer oscillator sections. And there's, how many crystals here? 8? All right, there's 10, but there's 30 bands. So some of these crystals, they use the harmonic, the second harmonic or third harmonic. They don't use the fundamental frequency of the crystal. So when you turn this knob, it's like turning magic. And there's other, besides the crystal being selected, besides the coils being selected for the band through this long wafer switch. I showed you that's the big wafer switch that runs to. There are cams. I showed you them in another video that move more coils up and down. Now, I do want to say at this point, now that I own it, I resurrected this on all the bands. One of the main things was the wafer switch cleaning. I showed you that using the eraser, using the hemostats. See, every day I do a little bit on this radio. I might clean maybe just one wafer. And the reason is I'm retired. And I don't want to just sit here on this radio for 6 hours straight. I break it up maybe 20 minutes one day, maybe a ½ hour the other day. And in between I think, what am I going to do next on it? Now, the thing when you're retired, I stay active. I go for long walks. I have to fit the long walk. I have to fit the weather. I have to cook. I have to have 3 meals for myself. And then you get the other stuff. Maybe I might have told you about cutting your nails on your toenails. Now, when you talk to old men about cutting their toenails, they lie. They go to someone that cuts their toenails. I still cut my own toenails. I could do a video on it. Your toenails get super thick. Cutting them grosses me out. Every so often, you know, my fingernails get long. Time just is speeding by, and there's all these things that I have to do just to get 20 minutes free to come over and do a video on this radio. But I have been thinking about it, and one of the things that pops into my mind is Rube Goldberg. Look it up, Rube Goldberg. He had all these different weird-ass things. If you ever saw Pee-wee's Big Adventure, in the beginning, the way he makes the toast, this thing comes down and hits this, and egg rolls down. Well, that's basically how this radio works. Somebody sat there and said, you know, it'd be amazing if we could have all the components in the RF section all tuned together. And they did it. And they did it with coils. They didn't do it with tuning caps. Because by using coils, they could have more sections. If they had gone with a capacitor, let's just say we'd have to have 8 sections. So they went with tuning coils. Now, the thing in my mind is, I'm looking at some of the coils, and I do realize that you could take a coil and you can make it tune a wide range of frequencies. But what happens with a coil is it gets muddy when you get out of a certain range. Every coil and every capacitor come together to make a Q resonant frequency. So if there's actually books that show you, they have charts, and you take a piece of ruler and lay it on there, and you want a certain frequency, and then you lay it down in one direction. It gives you the capacitance and the inductance, and you want it to fall within a certain range, and that gives you the optimum capacitor and inductance for the most Q. And this radio, obviously, I won't say they dumbed it down, but they allowed it to design to be a little, I won't say downsized. In other words, they had a compromise. The word is compromise. In order to eliminate a bunch of parts, they compromised on the coils. Now, if you take a BC348, you notice there's 4 sections with coils, in each one in a box. And there's sets of coils. Also, this radio comes in a smaller version, Collins 51S, I believe it is. And it's got a boatload of little coils. And they compromised there. Again, see, as the coil gets smaller, your Q goes down. But if you have more amplification, and then later on in the circuit you have some ceramic filters, you can compromise and get away with it. And that's what they're doing. And that's when I see a schematic, I'm going, what the hell is this? Why are they doing it this way? Well, this is a transitional radio. In other words, they were tuning everything. They tune the front end, they tune the mixer stage after it comes out of the mixer, and maybe one more time after another mixer. I still haven't wrapped my head around this circuit 100%. Now, I told you the AM broadcast band has 3 mixers, and it still has poor sensitivity. Now, the reason you want more than one mixer is you want selectivity. I explained to you selectivity. Sensitivity is the ability to receive a station far away that's really low power. So your radio is sensitive enough to pick that station up. Now you're listening to that radio, and one day you turn it on, or listen to that station. One day you turn it on, and you notice there's a big station on an adjacent frequency that's close to you that's really pumping out power, and it's bleeding over onto your radio, and you can't hear the station that's far away. Your radio has sensitivity, but it doesn't have selectivity. So now you have to buy a radio that has both sensitivity to get the station that's far away and selectivity that you can pick that station up without something on an adjacent frequency bleeding through. Now this set was made to be a dual conversion, and that's what it is. If someone had a very sensitive single conversion radio next to you on a desk, and they had this thing, a dual conversion, on the same desk, and you went back and forth listening to what you listened to, you might say the single conversion radio is more sensitive. It gets more stations. Well, this is made for ham radio or military, and they count on the fact that when they're in the aircraft and they're flying along, they have a bunch of planes on different frequencies, and they need the selectivity to prevent somebody being close by from splashing their frequency. They really don't need sensitivity as much as they need selectivity, because they're very close together. And when transmitters and receivers are very close together, they do all kinds of weird things. So in this thing, they just started making everything tunable. And I can't tell you how good the Q is on any particular band on the coil, because that's really expensive equipment. But I just wanted to tell you, or show you, when you tune, I'm going to do it again. You should see this bottom gear move, hopefully. Did I bump the camera? No, it's right here. All right, you're going to see it move, and then we're going to go to another detent. And there's the detent. So while it's going between detents, it's moving coils in and out, and it's selecting different coil on a wafer switch. This video is very hard to do. This radio is not your standard AA5. You know, guys do videos on kitchen radios and they're trying to fix it and they give up. And I'm just sitting there going, yeah, you should have a Collins radio and spend 2 or 3 nights just with an eraser trying to clean the tracks on the wafer switch. Forget changing the capacitor and changing resistors. You're in there hour upon hour trying to get the right angle, maybe taking a shield off. I showed you that. Just to get the angle for the hemostats, holding the piece of the eraser just to clean off the oxidation on the track of the wafer switch. And I've been doing all the wafer switches, and some of them are really incredibly bad. Now, if you move them back and forth, the controls, you will see a scratch mark through the wafer switch oxide. In other words, if you were to move the controls back and forth several times, working them without liquids, they would start to self-clean themselves. And that's why when you spray that stuff in there, how much does that really do? A lot of it's just you're going back and forth and you're self-cleaning the contacts. They're made to self-clean. But over the years, if the radio sits in a damp place, not corrosion, oxidation happens. And, you know, you spray this and you lubricate it, and then you pass it off to somebody else. Now, on this one, certain sections of this radio have been sprayed with that liquid that I won't mention the name of. Now, in another section, I found, I think it was WD-40. I had to clean that off with a, it looked like running tar in one spot. So someone has sprayed some type of cleaner in a different section. And everywhere I go on this radio, I find the nuts have been not fully tightened up. Someone's gone in there, they tried to get this thing working, and what it turned out to be was just, I found, was the controls were so, the wafers, they're corroded really bad, past anything I've ever seen before. And I've seen silver contact switches that really turn dark black in a Panasonic radio. A radio that was only 6 months old when I bought it. Suddenly it wouldn't record and play back. So I opened it up and I did some ohm meter checks of this push to talk type switch, and I wasn't getting any continuity. So I knew what I was going to find inside. So very carefully took the back of the radio off, and sure enough, all the contacts in that switch were silver. But that radio, that switch itself was probably somewhere in a warehouse before the radio was built. And the silver has a nasty habit of turning black. Silver spoons do that. Capacitors in radio produce silver mica disease. What happens is the oxide from the silver starts peeling off, and it's conductive. And it starts to short out the IF cans, and you get the crackling noise. There's a lot to these radios, but I just wanted to show you that I'm going to vacuum the gears and work them with a toothbrush. Then I'm going to oil them and grease them. I'm not disassembling this radio. This radio is not worth this. I resurrected it. It works on all the bands. I had the CBers on one night on the 27 megahertz band. Some of you would say, oh, that's 10 meters. It is 10 meter. I think 10 meters is like 28 megahertz, something like that. You know, and a lot of people are, well, you didn't show it working. Go away, go away. Those videos are a dime a dozen on YouTube. I'm explaining to you what's inside this thing before you buy it. And then when you watch it, you say, well, that's more than I want to get into. And there are websites where guys have taken this radio totally apart and cleaned it up and put it all back, rewired the capacitors. I'm not doing that. I'm looking at, right now, I'm looking up at the top. There's resistors and stuff in this radio that look like they're biodegrading. This thing's real in rough shape. And looking at it from the outside, it looks great. So I don't know where it was stored, how it was stored, but little by little, I've been cleaning that the wafer switches up. And some of the bands that were sort of working really good now. And you know, I checked the oscillators out. This, if I'm still in the frame, this oscillator here, when you measure at the tube, some of these higher frequencies on the scope, it'll be a very small sine wave. I measured it back at the first mixer. These signals go over to the first mixer. There's a capacitor that goes over there. I think it's a 2 picofarad. Put your scope on the plate of the first mixer, and you can see would be the oscillator for the first mixer is there. And you know, and then the other way you can do is you can put a radio nearby on the frequency that crystal is, and you got to look at one of the charts or in the manual to tell you what crystal is being used for that band, and that's the frequency you set your radio at. And when you switch your band control to that band, you should hear it, you know, a dead carrier in your radio. There's a lot to this. You know, I was up to this. The mechanicals got me, and I was an electromechanical repair guy. I did aircraft stuff, but this is no fun because it's not really made to be serviced easily. And to get at these gears here, you got to take the whole front panel off. And then there's all kinds of unions, or what do they call them, universal joints in this radio between the shaft and the wafer switch. And some of the wafer switches, they're actually mounted to the frame in one spot to shore it up. And if you had to take that wafer switch out and repair it, it's going to be a full day work. And that's why these radios in really good shape go for a lot of money. And like I said, I went for the bottom end. You know, I don't think $500 something was really the bottom end. And I think that's it. All right, that's it.